Hello, this is Shakib Ghazi and we're discussing about geometrical optics, and today we'll be studying about Snell's law. And in Snell's law, it's actually about a ray coming from one medium to another medium. Suppose a ray coming from medium A to medium B, and if we have the refractive index of medium A and medium B is nu A and nu B respectively, then we can say that nu A into sine of angle of incident is equals to nu B into sine of angle of refraction. So using this law, we can do one math. The math is about a tank filled with water, and it says that the height of the tank is 2.5 meter, and if I place one light bulb, it's actually a light bulb. It's actually a light. If I place a light at 2.5 meter distance from this perpendicular line or from the edge of the pond, at this point, and if the light is emitted, at what angle the light will come out from the pond. So that means you have to find the angle of refraction. So see, if we consider this as a triangle, we can find that the angle theta, incident angle, is actually, the incident angle can be found by using the tan theta, that is the opposite side divided by the adjacent side. So we have the opposite side as 2.5 meter and the adjacent side as 2.5 meters. So tan theta I is equals to tan inverse 2.5 by 2.5, that is 45 degree. So using the Snell's law formula, we can give the medium where the angle is being incident. We have to take the refractive index of that medium, that is nu W, and refractive index of water is 1.33. So 1.33 into sine of 45 degree is equals to 1, because it's actually being refracted into air medium. So then the refractive index of air medium is 1. So 1 into sine theta r. So by equating this, we can find the value of theta r, that is 70.13 degree. Again, another math, if we see, it's given a slab of glass. So it's given a slab of glass. So it's being told that a ray is being incident, making angle 60 degree with the normal. That means the incident angle is actually 60 degree. And the thickness of the slab is 5 centimeter. And since the slab is made of glass, the refractive index of the slab will be 1.55. Now the first question they have asked is to find the angle of refraction. Okay, so first one thing, see, at first when we are projecting the ray, so the ray is being projected in this way, then it will bend towards the normal, and again it will go away from the normal. Now see, the angle in which the light was being incident and the angle the light emerges out of the slab with the normal, obviously, will always be the same. That is, this angle, and it's given in the question, is 60 degree, and the angle making which the light comes out will also be 60 degree. Now they have asked to find the angle of refraction. So angle of refraction, so we will be using the Snell's law, that is nu 1 into sine 60, nu 1 into sine I, that is sine 60 degree, is equals to nu 2, that is 1.55 into sine r. By using this formula and equating this, we can find that the value of r is equals to 35.26 degree. Now the lateral displacement. What we mean by lateral displacement? Lateral displacement is, suppose if there were no glass and we were projecting a ray in these directions, it would have been, the ray would have been gone in this way, in a straight way without bending. However, since we have put a glass slab here, the ray was actually bent and then again did go out away from the normal line. However, it didn't go in a straight line, and we have seen a deviation. We can see that the ray, if there was no glass slab, the ray would have gone in this direction. Since there is a glass slab, the ray was going in these directions, and now we have a deviation due to the glass slab of a length of x. We have to determine this length of x. Now see, if we consider the triangle ABC, ABC, see this is a right angle. We always, why this is a right angle? Because we always know when we are measuring any distance between points, we always measure the least distance, and the least distance is the perpendicular distance. So this is the perpendicular. So if we use sine del, del is this angle. Now suppose if the glass slab was not here, this ray would have gone in this line. And since this is the normal plane, if I draw it here, if this is 60 degree, this will also be 60 degree. We know from our childhood concept that is the vertically opposite angle. Now again, it's told that this is 60 degree, this will also be 60 degree. But we are taking this triangle, so when we will be talking about this angle, and let this angle is del, so del will be I minus r, that is this entire angle. Let me show you here. Suppose this was our 60 degree, and this is our the bended ray or the refracted ray, and this is that angle r. Since this angle, this whole angle is theta I, that is 60 degree, and this angle is r, and if we consider this angle to be del, then we can say that del is actually 60 degree minus r. So that is del is equals to I minus r, and I is the angle of incident is equals to 60 degree. So if we consider the triangle ABC, we know it's a right angle triangle, so you can use the trigonometric ratio of sine del. Now sine del we know opposite by hypotenuse. So sine del is equals to opposite. The opposite is this line, that is the lateral displacement, or x divided by hypotenuse. Since this is the right 90 degrees, so the hypotenuse will be the opposite side, that is s. We've considered the length of this side is equals to s. However, we don't know the value of s. So we have to find the value of s eventually. Now again, if we consider this triangle, suppose this triangle name is ADB. Again we see this line is also 90 degree. So since this line is 90 degree, we can say this is also a right angle triangle, and we can again take the trigonometric ratio, that is, if we take the trigonometric ratio of cos, that is cos r, we are taking this angle, and we have told you that this angle is r, so cos r is the adjacent side by hypotenuse. So what's the adjacent side? AD is the adjacent side. And what was AD? AD was the thickness of the slab, and that's given as 5 centimeter. That is, so we can write as D by hypotenuse. Since this is the right angle, so this will be the hypotenuse S. So we can say S is equals to D by cos R. So sin del is equals to x by s. Del we can write I minus r is equals to x by s, we can write D by cos R. Now we have the value of D, that is 5. I minus r, I was 60 degree, r was 35.26. We will be having the value of this one also, and now equating these equations, we can get the value of x as 2.56 centimeter. Again, another question is angle created by the emerging ray with the glass plate. This is actually a very easy thing. This is the angle created by the emerging ray with the glass plate. So the ray is being immersed in this way, right? So with the normal, it will also create an angle that is equal to the angle of incident, that is 60 degree. So since this is a complementary angle, that is the summation of this angle and this angle will be 90 degree, so we can write this angle as 90 minus 60, that is 30 degree. and another is angular deviation. Angular deviations that I have already told you. The ray, if there were no glass slab, the ray were supposed to go in this direction. Suppose this was the normal, in this direction, that is creating 60 degree here and 60 degree also here. However, since there is a glass slab, the ray will be bented in this direction, creating an angular deviation. So what will be the angular deviation? This will be the angular deviation. So the angular deviation will be the total angle I, that is 60 degree, minus this angle, that is the refracting angle, that is I. And we will be getting, that is the actual the del value. So we will be getting the value of del as 24.74 degree. Now time needed to traverse the glass. Sorry. The time needed for traverse the glass is actually, we know the formula S is equals to, S is equals to Vt, so T is equals to S by V. Now the twist in this question is the value of V, or the velocity of light. Now the velocity of light is not same in every medium. For example, in the air medium or vacuum medium, the velocity of light is 3 into 10 to the power 8. But in the glass medium, the velocity of light will not be 3 into 10 to the power 8. It will be way lesser due to the fact of the glass having higher density than vacuum or air medium. So how we can find the velocity of air from of the glass medium is actually the formula we had from the first video. It's that the refractive index of glass medium divided by the refractive index of air medium is equals to the velocity of light in air medium by the velocity of light in glass medium. In that way we got that if we divide the velocity of light in the air medium, that is 3 into 10 to the power 8, by the refractive index of glass medium, we will be having the velocity of light in the glass medium. Now if we put the value of S and CG, we got the value of S from here. S is equals to d by cos theta r. So d by cos theta r, and CG will be having the value. Okay, sorry, I have not written the value. You can find the value since we are too smart. So this was all about today's lecture. I have no idea when we will be making the second one. So I hope you liked it. Please like, follow, or do whatever. Just study. That's the thing. And goodbye.